to preview on his presentation. So our first talk will be by Dr. Rajiv Prabhu. Dr. Rajiv.
करो कहाँ गए करो नहीं
Dr. Rajiv, you have 15 minutes.
Yeah. So good evening, dignitaries, and I think I'm one of the scientists from basically from the physical sciences. And thanks Dr. Vilawar and Dr. Dixon, and giving opportunity to Hariba to present this case here. I don't want you to go through this introduction, but let me straight away then go to the precise. Sorry, it's not moving.
कंप्यूटर देखो अगर हैंग कर रहा है पर कंप्यूटर नहीं कर रहा है
It's not moving. I don't know. Sorry.
मैनुअल कर दो
No, even you can do manual, no problem. It's not happening.
बंद कर दो स्लाइड और स्लाइड
Yeah. So this is the corporate overview of Hariba. Hariba is the name of the company. It's the name of Mr. Hariba. As we know, this Tata Birla, like that, for the surname, it comes like Hariba, so it has come name Hariba something. You may be sounding difficult to name as a Hariba, but that from where that Hariba has come, and that was the surname of Astuchi Hariba, who is the chairman and group CEO right now. And he's based out of Kyoto headquarters. 1945 is founded, and then it's close to 224 billion GPY is the global turnover of the group, around 8,000 employees. And this is basically is an engineering company and a lot of products. Of course, as we are today in the NPL and this on this conference here, so we are also measuring a lot of instruments for measuring, especially emissions and other things. So that's why how it makes sense for us to be here. This is the way a Hariba world looks like that. This is the touching the human life, whether it is agriculture, fishery, or the global environment, or the vehicle, or the health and safety. And that's how the various human say this touches the line. This is a basically five businesses, which is the automotive, which is we do make a lot of products for automotive R&D for the emissions equipments, process environmental for pollution controls, and then medical, we have a products for medical hospitals and the laboratories. Semiconductor, we make a lot of mass flow controllers, and scientific, we basically scientific product like Raman spectrophotometer and fluorimeters also. This is a global journey. I would not like to go through, but from 1945 to 2020, we have close to 44, 45 acquisitions, and it has gone through the acquisitions by in various spheres of the life. I don't know something again. Sign the name.
स्लाइड मूव करके देखना है कीबोर्ड से करिए
No, I'm really doing from keyboard only. These are the various R&D and the production sites across the world. You can see the basic production, and there are 48 companies across 27 countries we have.
आप देख लो एक बार
global. Yeah, till now it was more of a global. Now we are talking about this is the Hariba India, which is the Indian subsidiary of the group. This is the evolution. We started in 2006. So, and these are the various activities that happened across up to 2020, 2022 when we started here. So I don't want to go through, but various has been, this has been our journey and evolution of the organization. This is our all India offices, our various offices and two factories we have. That is across our production and the offices across the country. This is our technical center, and that's why I think this is one of the reasons of being here. That can we have something calibrations or something like this? We have our own calibration facility for the vehicles here. So can we have together something to do with the NPL? That has been our discussion. So this is our facility at Pune. This is our portfolio for the basically for mass flow controllers, which is basically used this as a in various all the machines these days is being used as a mass flow controllers, and we have almost have a monopoly situation as far as the mass flow controllers in this category is concerned. This is we also have a calibration setup at Pune, and that's how we can club together with the NPL. Let's see how we can go through that. This is our total reach. There we have more than 550 people in the organization across the country to serve our customers. Now I would like to give to my colleague, which is talking about the monitor of PF375, which is maybe of the interest of you for the ambient monitor.
I'm Kyohei Nishizawa. I'm from Horiba Limited Japan. And using this opportunity for me, I want to talk a little bit about one of the ambient quality monitoring products, PX375. I think I cannot cover all of them, but quickly I'll explain the benefits of this instrument and then how this instrument is utilized in the field. So when you think about pollution, PM is always a main concern. But if you take a look, closer look at it, they are a lot diverse in terms of shape or size, depending on the pollution source. And if you look at the components of it, it's composed of elemental carbon, organic carbon, inorganic carbons, and so on. And this particular instrument, PX, is able to monitor the PM mass concentration and also the composition of metals in it. And the question is, why do you only want to monitor metals in ambient? The answer is metals are hard to chemical react in ambient. That's why it doesn't change the composition over the transportation from the pollution source to the measurement location. That's why the metal concentration is a very critical information for you when you want to do a pollution source analysis. So PX375, very simple, sampling, PM mass concentration measurement, metal concentration measurement, those are all completed in one unit on site. And we use beta rate attenuation technology for PM mass concentration measurement and XRF technology for metal concentration measurement. It gives you a nearly real-time measurement, shortest from 30 minutes. And it will give you continuous monitoring that realizes time trend monitoring. You can monitor all of these elements with the blue cells, and I'm also listing LDL for each element here. This is the internal view of the instrument. If you open the door, there's a filter tape installed with the rollers. And the sampling head is taking PM from air. And the sample is trapped on the surface of the filter tape. And at the same location, PM mass is analyzed with the beta rate attenuation. And then the roller will advance the filter tape a little bit. And then at the next position, metal concentration is analyzed with XRF technology. So the good thing is conventionally ambient metals, I mean, right now also, but most commonly metal concentrations are analyzed with the manual method. Most of the cases I believe ICPS. For this analysis method, it's an expert analysis, so expensive. It takes a long time to complete result acquisition. It usually takes 2 weeks. Since usually it's one-time measurement in a day, difficult to grasp rapid trend change. So what is good about applying this technology is in terms of time resolution, since you can analyze the data every 30 minutes. For example, in the daytime, rush hour, you have more pollution influence from vehicles. You can also grasp this influence. So not just one day average, but you can grasp the change in the time of day. Pre-treatment is not needed. It's all automated, easy to install, easy to operate. And also it leads to reduction of man hours required for analysis. Measurement data, you can get more. That helps you to smoothly analyze the pollution source. This is showing the example of the difference, how the measurement data will look like in comparison with manual method. You can obviously see the sharp peak within 1 hour. Those are the list of applications you can deploy the instrument for. For example, in Japan, Ministry of Environment is using this instrument at the 4 locations domestically. And some of the research institutes are also using for pollution analysis. Some private companies are using for fence line monitoring. And in some cases, they want to measure the direct emission from stack. Yes. And for example, mercury analysis is also interesting. In Japan, the government is monitoring, municipal government is monitoring also the mercury concentration 16 times a day, but they are not monitoring other metals. They are only monitoring other metals manually, one time in 7 weeks. If you are monitoring not just mercury element, but also other metals too continuously, what you can do is you can utilize all the measurement data to analyze the pollution source. So this is an example of the case. On the left side, I listed an example of representative indicators of pollution source of mercury. Coal or cement plants, those are common pollution sources of high mercury. And on the right side, you have mercury concentration for red and lead and zinc ratio for green, and red and zinc ratio for yellow, and calcium concentration for green. And what I'm telling here is you can see 2 peaks for mercury concentration increase, but lead zinc ratio and calcium concentration, those are only synchronizing for 1 peak. The first mercury increase from around 6 a.m. to the noon. This one is synchronizing with the lead zinc ratio. Lead zinc ratio is representative for pollution influence of coal. That's why you can make assumption here. Oh, the first peak, first pollution, mercury concentration increase is having correlation with pollution source related to coal combustion. And likewise, you can do the same pollution analysis for cement facility for the second peak. This is a kind of examples how you can utilize the ambient metal concentration. We also do data visualization like this, and also data analysis method called the PMF, positive matrix factorization. But this requires a lot of measurement data, so sometimes it's not practical. So we are also doing manual method too. For example, this one, you are seeing time trend of wind speed and the concentration of iron. You can obviously see correlation for those 2 factors. Kind of assumption you can make around here is the iron is only blown away from, for example, a plant when a certain strong wind is blowing. So if you want to reduce the concentration of iron at the specific location, maybe one of the countermeasures you can take is to build a fence in between. Yes. And this is I think, the last case. We also have one project going in Japan that's a smelting facility, and they always wanted to reduce the pollution, particular metal concentration. And what we did is we installed PX375 in background measurement, and another one right next to the plant and measuring the concentration of two locations and also the operation of the plant. So doing the data analysis of those, trying to find the correlation of those factors. Finally, we were able to find the most effective countermeasures to reduce the pollution. Yes, that's it from my
Timing.
side. Thank you very much.
Talk is now open for discussion. Any questions? Questions?
Also provide the services.
Yes, exactly. Yes.
This function, then the service is to the neighboring. I have one thing. In your Nagpur, what factory, what is product produced? Sir, currently Nagpur we have majorly it is for medical agent manufacturing. But in the big facility, we have planned for the environmental. Haridwar. Haridwar also is
एक और ले जाओ। और नहीं है, एक मिनट, एक उधर है, मैम के पास है।
integration facility for environmental production. Even production also integration under the Make in India initiative. We have the facility for same cell like the gas. Also for the ambient and the complete water packages we produce. It is not only product, but the complete solution we provide.
But I was looking in the mail, that's why I asked.
Yeah.
Well, I know.
Thank you.
Yeah, I have one question. You have said that you have shown that the past part that Horiga has already going for the system of the vehicles and emissions. And Pune, I think it is Pune.
Yeah.
There is another in IRI, I think ARI. ARI also doing it. Yeah, they are also doing the same thing. So how basically you are
So they have our equipments. IRI, ICAT, all these companies, they have our emission equipment which they are using to checking the vehicles of the customers. So we provide them our emission equipment which they are using. And they are the service provider with our instruments.
Thank you. I was hoping to see some of the Raman spectrometers also, but unfortunately that's not mentioned. One specific question is, Horiba used to have a very good model, T64,000, but that has now been discontinued. So which model has replaced that performance gap?
I'm sorry, we had to connect over the scientific team for that
Okay,
detail.
fine, that's it.
But yeah, I just know generalize that we have the high-end Raman evaluation system. I think you know very well about T64 that series. We'll get back to you.
Thank you.
Thank you for the question.
Yeah, thank you, Mr. Kawasa and Nilathan for your presentation. Actually, this presentation was done day before yesterday when we had this Air Expo presentations. I just have because we already discussed many things in that, but just one question that what you said that you have an emission measuring facility at Pune. So do you have also, I don't know, but Horiba is making the emission, particle emission instruments also?
In our scientific division, we have the particle size analyzer based on the laser diffraction, dynamic light scattering, but not the particle counter. Hope I answered. Thank you.
So thank you. That finishes this presentation. We go on to the next one.
Yes, over. Yes,
next presentation by sir. Geological Survey of India. He is principal scientist of Central Institute of Agriculture Engineering.
The incomplete.
He has 15 years experience in the principal scientist with a demonstrated history of working in the farming industry and skill in the rural development and energy management in the agriculture, impact assessment of technologies, R&D, and the agricultural mechanization, market research and development. Strong financial professional with PhD, focusing in agricultural economics, with specialization in energy management in agriculture from the NDUAT Faizabad, UP. I request Dr. Radhesam Singh to deliver his lecture, and hope that the audience will take that lecture.
Thank you, sir. Good evening to all of. And let me correct my introductions. I am currently working in the Geological Survey of India. It is a attached office of Ministry of Mines and central headquarters situated in the Kolkata. It is supported by 9 regional headquarters across the India, and which is further supported by operational offices that is headed by Deputy Director Generals. It is meant for the delineation of the council towards body of the country and mineral perspectives. Apart from that, I worked in Ministry of Finance, Indian Custom and Central Excise, followed by the Ministry of Defense, Director General Quality Assurance, and subsequently in 2009, I got the opportunity to work in this most prestigious and oldest department, you can say, which is inception day was the 4th March 1851, and serving the nation till now. This is a brief introduction. And my before coming to the quality management systems, inter-laboratory comparisons, and accreditations, I want to extend my sincere thanks to the organizing committee, that is NPL as MSI, who has given me opportunity to deliver these talks, and especially the coordinators and sub-coordinators who has given me opportunity and extended their logistic supports that could result to the I am here. Before defining this quality management systems, it is most pertinent to discuss the few elementary might be you are well known. What is quality? So many talks after delivering I concluded that what can be called as a quality. It may, as the definitions, it may be defined as the totality of the required inherent feature in a particular item or service, which is fit for intended purpose. This definition is fine. Now, this requirement set the basis of a specification formation. As you are aware that 100% in spite of good laboratory practices, good manufacturing practices applying, no one can deliver the 100% product or service without any slight deviation. That's why to catering the service, you want some bit relaxation in their products. And that is defined by the customers. That is upper specification limit and the lower specification limits. You are very much aware about this Six Sigma concept. This is a product, define, measure, analyze, improve, and control. And this is working on 6 standard deviation. Once you are approaching this one, out of 1 million opportunity, only 3.4 opportunity can be outlier of this upper specification limit and lower specification limit. And this is a 0 is the average values are required and specified what is your requirement as per your specification. Sigma is the deviation from the average value. If the requirement is not fulfilled, then what would be the consequence? Ultimate rejection, lost, and your product will be recalled. It is not a uniform. Particular requirement set the basis of specification formation, and individual requirement differ from each other. It cannot be same for all. For a particular example, I am just taking very simple example, that is milk. It can be classified broadly in three categories based on the fat content: full cream milk, reduced fat milk, and skim milk. Now question raised, which one kind of milk is going to suitable for the growing child? Which one is suitable for young man, and which one suitable for the old aging man? As you are aware that for a growing child, this reduced fat milk meets his requirement, the metabolic requirements, and it can fulfill his requirement. That's why it's called as a quality product for him. So both kind of milk are very good and having some inherent feature in that also, but they are not going to fit for his metabolic requirement and not suitable. That's why they are get rejected. Similarly, the young man, full cream milk can fulfill his daily requirements, and in the similar man, for the skimmed milk is the most suitable for the old man person. The quality product. What is called quality? Quality product is absolutely fulfill the user requirement. That is, quality is defined by the customer, and customer is the king. And any manufacturer and service provider has to meet his requirement. This is a basic elemental principle. Since any are already covered, so allowed tolerance, I already stated, upper specification limit, lower specification limit, that has been given tolerance. That set the basis of formation of the testing and QA inspection or check. Objective of QA is to narrow down this delta or standard deviation so that the all upper specification limit as well as the lower specification limit can be accommodated within squeeze. Because once you are deviating from the one standard deviation, you are going to 1,000 out of million. The 1,000 opportunity of improvement is going to out of range. So what will be ultimate rejection of your item? To cater this kind of quality, you need the very sound and dynamic, robust quality management system. A quality management system is a collection of policies, procedure, plans, resources, just a definition ready, processes, practices, and the specifications of the responsibility and authority of an organization designed to achieve product and service quality level. What? Paramount customer satisfaction and company objective. Why quality management system may require? For consistent quality product delivery, achieve the desired goals of customer satisfaction, monitoring all the activity as per defined procedure, as well as describe the opportunity of further improvement through the feedback, through the management review, through the internal audit. These are the tools to get the opportunity of improvement and for further improvement of your system. These are the basic principles of the quality management system. First, paramount top, customer focus, leadership, engagement of people, process approach, involvement, evidence-based decision making, and relationship management. That is these are the principles, and it is stand like that. Customer focus. First, you need understand the need of customer, meet the requirement, and only after that you have to exceed his expectation. Then you can sustain in market. Leadership. Top management should first of all unify the purpose and objective. Any organizational direction should be very much clear what to do. And after that, direction, you have to empower them to do carry out the particular job. And only in this way, any organization can achieve its objective. Involvement of people. Once you involve all your stakeholders of the pupil, only the desired objective can be achieved. And it is the most beneficial also for the organization. Involvement of pupil is a fine process approach. All things should be as per documented, well-written process, and that can be controlled and processed and managed as a system. Because you are no for doing anything, system is very much important. Continual improvement. This is applicable in every walk of life, permanently applied to the organization, its people, their processes, their system, and their products. factual approach of decision making, decision based on the accurate, relevant, and reliable data that come from customer feedback, internal audit, management review, and external third party assessment also, giving you as a non-conformist that is opportunity of improvement. What is prevailing in your system? Mutually beneficial supplier relation, organization and suppliers benefit from each other resources and knowledge. Now coming to the most and paramount important point, that is quality policy. Describe the organization approach to quality. Quality manual is the policy document of any organization in which the quality policy is defined and address each principles of ISO IC 17025-2017 for the testing laboratory and other standards, that is a 15189, that is medical, and 17034 for the RMP and 17043 for the PT providers. A general hierarchy of the document is paramount of the quality manual and procedure manual second, and work instruction and forms and format. Quality objective, quality related to goals related to the quality must be synced in with the quality policy, assigned the organization function, track to the top management. Quality procedure is what is quality procedure? If description of step by step for the company does to meet the policy. A procedure for each elemental principal activity, process for procedure that affect the quality. Now coming to the next, because my topic is containing the fourth topic elementary. Now inter-laboratory comparison. What it is done? By definition, inter-laboratory comparison is organizational performance. And how it can be checked? Evaluation of measurement or test on the same or similar item by two or more laboratory in accordance to the predefined criteria. Means what parameter to be get tested, particular from all applied scope. Which one parameter a laboratory desires to test, and it comes as a ultimate Z score. That is nothing, just your observed value minus mean value divided by standard deviation. And another tool that is most acceptable tool, that is the proficiency testing evaluation, though it is inter-laboratory comparison, but it is being organized by authoritative agency against a pre-established criteria that is being accredited in compliance to the ISO IC 17043 and also following this standard. That's why it is different from the ILC. And in intra-laboratory, that is internal quality control, and these two are the external quality control tool. First, you have to check it out your own house, then you have to check with others. These are applicable during the standard formation, validations, even CRM developments. These are the techniques well applicable. Now, what is the laboratory accreditation? Well, before this, some little bit throw by QCI members, my colleagues, but I am just reading. Laboratory accreditation is a procedure by which an authoritative body, that is accreditation body, gives a formal recognition of technical competence for a specific test or measurement based on third-party assessment and following international standard to conformity assessment body, that is laboratory, which include testing laboratory, medical testing, calibration laboratory, proficiency testing, etc. But the question is, throughout the global, how it who will govern it? So for that, for catering the accreditation service globally, International Laboratory Accreditation Corporation, founded in October 1977, Copenhagen in Denmark, and the ILEC started its conference in 1977 from the 24th October to 28th October with the aim of developing the international cooperation for facilitating trade by promotion of the acceptance of accredited test and calibration result. This is the beauty of the accreditation. It can work the global framework and no results. One test, one item is get one time tested, it will be accepted everywhere. I need not to get again retested. The purpose of this arrangement, that is ILEC, International Laboratory Accreditation Mutual Recognition Arrangement, often referred to AMI, is to create an international framework to support international trade through the removal of technical barriers that a test are inspected once, accepted everywhere. ILAC is an organization that counts its member laboratory accreditation body. That is in India, laboratory accreditation body is in India. But regional organization that is APEC and stakeholder representative over here is a collection 115 economy at this moment. The MRA signatory of this ILAC. The ILAC MRA, what stand? MRA allow you to make use of global network of testing and calibration laboratory and inspection body that has been accredited to provide objectively to accurate and reliable result. How? Because they are already assessed in compliance to the international standards for testing laboratory 17025 for medical laboratory existing another standards. So accreditation body how? Accreditation body that has been peer-evaluated means in Asia Pacific APEC regions, the one accreditation body is coming to evaluate their individual operation. They are governed as per the 17011. So whether they are doing as per or not. Evaluated, competent and signed regional and international arrangement to demonstrate their competence. These accreditation bodies then assess the and accredit conformity assessment body that is laboratory. In Asia Pacific laboratory accreditation was established. Asia Pacific Accreditation Corporation was established in 1st January 19 by the amalgamation of two former regional accreditation corporations, that is Asia Pacific Laboratory Accreditation Corporation and Pacific Accreditation Corporation. These are just your importance. In India, National Accreditation Board of Testing and Calibration Laboratory and NABL is the constituent board of the QCI under the aegis of the Department of Policy and Promotion, Ministry of Commerce, EJ. MRA signatory as well as founder member of APEC and ILAC provide the accreditation for conformity assessment body that is testing laboratory, including the calibration laboratory, as per 17025 testing laboratory. Also, the 17025 medical laboratory ISO 15189 proficiency testing providers 17043 and reference material as per the 17034. The MRA. Duty of this MRA facilitates the acceptance of conformity assessment body laboratory results across the region and with the region, with other regions around the world. Now coming to why should go for accreditation? Now it is, though you are following, so you have been assessed for the in light of international standards. That's why you got the international recognition. Access to the global market. Because on a very accreditation bodies portal, there is a directory of accredited laboratories. So that globally your laboratory position can be assessed. Confidence and satisfaction. Enhance customer satisfaction and confidence. Robust quality management system, continual improvement. Time and money efficiency. How it can come? Because once you have tested the product, it needs not to be get again tested whilst it is going to export in other country. It will be treated as like that their accredited laboratory has tested that item. That's why in this way, the removal of technical barrier is also observed. Robust quality management system, because you are following the very dynamic and robust quality management system, slight deviation even happen unintendedly. Then even that the quality will be not compromised at all. Because ensuring the validity of results under the class 7.7, you are following a lot of number of parameters. So one parameter, if slight intended deviation, you still the laboratory will give the tested and good quality of results. Prevent loss due to the defect. Continual improvement, how it will through the feedback, internal audit, management review, and followed by external bodies also. That is a third party assessment. Cost reduction. Once you are not needed to again retest, then the cost will be reduced and market credibility will increase. Prevent loss due to the defect. That is also applicable to manufacturing sector. Once any product is going to out of range, then again reprocess cost is going to more and more in. The ILEC MRI allows you to make use of the global network of testing and calibration laboratory and inspection body that has been accredited to provide the accurate and reliable result. The liberalization of trade and industry policy of the government of India has created a quality consciousness in domestic trade and provided the greater thrust for export. As a consequence, testing center and laboratory have to demonstratively operate at an internationally accepted level of competence, that is international standard following. Accreditation allows you to make an informed decision when selecting an organization to carry out your testing calibration activity as it demonstrates competence, impartiality and capability of that organization. As a result, accreditation helps to underpin the credibility of safety and performance of goods and services. This is the procedure. Yesterday, some questions answered. This is NABL laboratory accreditation process is that application filed by the CAP and immediately acknowledgement will be furnished by the NABL and the submitted document will be scrutinized by them. Once any deficiency, it is well informed to the CAP and within 15 days time, they have to give the corrective action and if found satisfactory, the one lead assessor will be appointed to review the submitted documents and if any adequacy found, inadequacy found, that will be again go to this arrow. It shows that the laboratory will get the informed. And after submission of this document adequacy report to corrective action to lead assessor within 15 days, it found satisfactory, then it is optional pre-assessment is to check the laboratory's preparedness for the final assessment. Whether they are really fit partner, if this is in light of 5PM concept, man, material, method, machine, measurement, and available of CRM. If found satisfactory, the pre-assessment report will be submitted to the NABL Secretariat. If any NC is going to raise during that assessment, they have to close within the 15 days. And followed by that, once found satisfactory, NABL will constitute an assessment team for final assessment. During that final assessment, the one lead assessor and in as per applicable scope and applied scope, number of the technical assessor will also be appointed. And 2 days or 3 days maybe depends on the scope, the assessment will be carried out. How the accreditation differ from the certification, there is a paramount one. During this assessment, the document verification, apart from documents, the personal testing capability and competency will be assessed. In this way, the accreditation is above the certification level. So after submission of this final report by the assessment team, are required to close the all raised NC within the 30 days. And again, it will be scrutinized by the NABL Secretariat and which will be presented to the NABL Accreditation Committee, and they will examine and further recommend. And on their recommendation, the director chairman yesterday was here. He will approve that grant of accreditation and then further issued by the NABL Secretariat. This is the entire procedure of this, and it is applicable for the 2 year. And during first cycle, on the first year, you have to face the surveillance audit. That is similar as the main assessment. And after completing the 1 year, in next year again, you have to face the renewable assessments and followed by the desktop. By subsequent year and third year, and in fourth year again, you have to go for the renewal of accreditation. These are fields, testing fields, chemical, biological, and the calibration field also, medical field also they are giving at the moment, and proficiency testing providers. These are also accreditation provided by the NABL, reference material producers. Even now recently the medical imaging conformity assessment body also in the pandemic situation they have started. This is very commendable and useful for the societal issues. Current scenario of the laboratory accreditation in India. Currently in India, more than 8,113 laboratories are accredited by NABL, which includes the 4,457 accredited testing laboratory test a multitude product 1043 accredited calibration laboratory ensure the metrological traceability of the measuring equipment and test results. And 2,546 medical testing laboratory in addition to the 17 reference material producer and 50 PT providers. And it happened due to the extra efforts of the NABL as well as the technical assessor who was has the two role, their own organization work as well as this additional national interest one. Because NABL has not a permanent employee of this kind of nature to having the various domain and expertise in nature. That's why they have been panel the several technical assessor in different various fields. Thank you very much.
Thank you, Mr. Radheshan. That was excellent time management and a very clear and lucid presentation about quality management system and maybe electrician system. So, the talk is open. Questions? Any points? Yes, Dr. K.P. also, please.
This ISO 17011, 2017. It is basically, I think it is basically for the internal audit of the NABL. Am I right?
Yes, the accreditation body is running under compliance of that one. And it is being pre-evaluated by other body also. That is a regional body or any ILEC body also.
But especially this standard is meant for the internal audits of the accreditation body.
Yes. It is not for the CAP.
It is not for the CAT,
Yes.
but it was mentioned.
Yes, sir. It is only for operation of accreditation body is compliance to the 17011.
Correct. Number two, chairman does not approve the accreditation. It is the CEO of the NABL who approves accreditation.
Sir. Signing the certificate is entirely different, but getting the approval on file is entirely different. That is being given by the NABL. You are aware that I am a government servant. I am a system. The higher body is giving on file approval. And on the behalf of that, we are communicating the decision. Try to understand.
But in all this certification, you will
Sir,
find
I agree. 100% agree with you. But CEO is not going to approve. Chairman of NABL every time is going to approve that recommendation of accreditation committee. Accreditation committee recommendation is directly going to chairman. And he, after his approval, only after that, he will communicate that decision in the form of certificate.
Okay, anyway, we'll discuss later.
Okay, sir, fine. And any question more?
Dr. Shivagan.
Hello,
Sir.
very interesting talk, sir. Just for curiosity, how this quality system is being implemented in Survey of India?
Yes. Sir, Survey of India is the Geological Survey of India because Survey of India is entirely different organization. Geological Survey of India, we are very much bothered about the mineral prospective. But to carry out the mineral prospective, we need to test the several media test sample, that is the rocks, streams, sediments, soils, as well as water sample. As you are very much aware that the detection limit is on surface. If you go through, the every element is not available. So I have to check it up to the very lower detection limit. And as per this in-house SOP, we have validated it. After that, regional office where state-of-art laboratory are there, XRF, ICP-MS, apart from the AAS are available, and entire 63 elements. We are catering National Geochemical Mapping Program. Here is also running. Apart from this, the mineral perspective, and we have categorized on the base of sensitivity and in area applicability. These 63 elements in various 9 packages. So, for each package, we have formulated a SOP and that is being validated. And further, this laboratory is get accreditation in that line of chemical testing, say as against for 17025. As of now, apart from this activity, it is well mentioned in first slide. Apart from the SI activity, I got the opportunity at several occasions for the assessment of laboratory in compliance to the 17025 technical testing. Time to time role is going to change, sometime TA, sometime TA. Any more questions related to this topic?
There are
Any?
no more questions.
Maybe silly, a small question, big question, that is not matter. Open to all. About accreditation, about quality management system, about quality, about the Six Sigma, have you any doubt, you can ask, open to all. About accreditation procedure, if you want any clarification, I can throw the some light, as per my analysis.
So it looks like there are no more questions. If anybody wants to discuss, we can discuss during the time. Thank you, Mr. Ravisha. Let's go to the next presentation.
Thank you very much.
Our next presenter is Mr. Pradeep Gujarati, Deputy Director of IGMI Mumbai. Mr. Gujarati is a BTech in electrical, and he has been working in the field of electrical metrology for last more than 7 years, almost 24 years. He's a member of BIS, MSI, and TAGMA, and he has visited Germany, NRC, Canada, and various other OEMs of reference standard manufacturers, and presented papers at various conferences. So over to Mr. Pradeep.
Always.
Good evening, and in the beginning, I must appreciate and thank you, the MSI and the NPL for giving us an opportunity to make this presentation. I express my sincere thanks in the beginning to Dr. Sanjay Yadav and Dr. S.K. Jaiswal for inviting us for making this presentation at this ADME 22. So today's my talk is the advanced calibration system for multifunction calibrator, which we are compiled. I'll not say we are developed, we are compiled at IGMI Mumbai. See, this multifunction calibrator is a very unique equipment and the required for the calibration of the various multimeters and all. So this is a very unique equipment which gives the voltage, current, the resistors, AC voltage, DC voltage, and the day by day these equipments are used in the various calibration laboratories, secondary calibration laboratories, and these are highly accurate equipments. And then the manufacturers are claiming very high accuracy of this equipment. And what about the uncertainty? When it comes for the calibration, the uncertainty is very important. And that's what we have compiled. We have purchased several equipments at IGMI so that though the accuracy of the manufacturer is claiming, it has to be certified by the laboratory, and that we have tried at our laboratory. That's why the central theme of today's talk. See, in the multifunction calibrators, we have the various parameters like DC voltage, AC voltage, DC resistance, DC current, AC current, and frequency. So we are using various standards. If you see the parameters, so for DC voltage, we are using the binary voltage divider system, and the Zener reference we are using. Then for AC voltage, we are using the transfer standard, and for DC resistance, we are using the AC-DC transfer standard. Then for resistance, we are using the reference multimeters and the bridge system. And for frequency, we are using the frequency counter, which is directly traceable with the rubidium clock. So these are the various systems we have established at the IDMI Mumbai, and by using this, we are calibrating one multifunction calibrator, which gives the several various parameters. So you can see this photograph. So this is the binary voltage divider system. This is for the calibration of the DC voltage. So DC voltage, actually though it looks like a very easy, so it is a static voltage divider. It is converted into the, earlier it was a manual system, now it is a same static voltage divider, but it is used in a auto calibration mode. So this binary voltage divider, what it does that it is using one reference, it is a 10-volt reference, Zener reference it is using, and that 10-volt Zener reference we are calibrating from the NPL India through the Josephson junction.
So that traceability we are taking from the NPL from the Josephson junction, and that we are using along with this binary voltage divider. This binary voltage divider we are standardizing with this Zener and directly transferring this uncertainty on the device center calibration, that is the multifunction calibrator. So we are first we are standardizing the binary voltage divider by using the reference Zener, and then we are removing that reference, and then we are connecting the device center calibration from the multifunction calibrator, and with that we are comparing the DC voltage of the multifunction standard with the Zener reference source. And with this, the uncertainty, if you take the circuitry, it is a directly, it is not a direct measurement, it's a comparison measurement. And if you see the uncertainties, the main part is the uncertainties here. So here the uncertainties are related to the binary voltage divider is hardly 0.05 micron, and then which comprises with the, because it's the auto calibration system, and it is also having the not only auto calibration system, but it's the auto balancing system also. So the auto calibration, the 0.09 ppm, then switch wiring connections, then detector loading, uncertainty due to the potentiometer. These all total uncertainty is hardly 0.05 microns with respect to the binary voltage divider. Then we are also using the Zener reference, so that's at least 0.1 ppm, and then uncertainty due to the stability of the supply source is 0.01, and the uncertainty due to the resolution of the multifunction calibrator, which is changeable as the multifunction calibrator is changing. This resolution is changing. So maximum uncertainty is 0.1 ppm by using the while calibrating the DC voltage of the multifunction calibrator. Of course, this totally depending on the resolution of the multifunction calibrator. If the resolution is different, then uncertainty is going to be changed here. So this technique we are using for the DC voltage calibration. Now coming back to the DC voltage is sometimes easy, but AC is little difficult. So AC we are using the transfer standard. And you know the transfer standard, the basic definition, actually the transfer standard they are using today, but earlier the word was thermal transfer standard. You know for calibration of AC, the thermal transfer standard is a very important equipment. The principle of this thermal transfer standard is a very easy, that whenever you the AC and DC effect, AC effect and DC effect of the is the same. So AC voltage effect and DC voltage effect is the same, and the thermal effect of the AC and DC is the same. That principle is used here, and in this the transfer standard there is a AC this RMS sensor is used, and what they do actually here, first we apply the DC voltage, and we are characterizing or we are noting it down the output of the DC voltage, then we are removing the DC voltage and applying the same AC voltage, so that it compares the DC effect, thermal or DC effect with the AC effect, and with that they are comparing the AC with the DC, and with this the uncertainty is very minimum, that is the uncertainty due to the DC voltage source, because that first we are feeding it to the thermal sensor, so that is 0.35 microns. Uncertainty due to the reference multimeter which we are using for the measurement of DC voltage output and AC voltage output, so that is a 3.2 microns ppm. Then uncertainty due to the temperature coefficient, then uncertainty due to the reference multimeter, and uncertainty due to the AC/DC transfer standard is a maximum so 5 ppm, and the so total comes for the AC measurement, AC voltage measurement comes to the 10 ppm hardly. Now the third parameter is a DC current calibration. Little bit here very simple phenomena is used, a simple formula. Everybody knows the Ohm's law, and effectively the Ohm's law is used. So when the current is flowing through a resistance with excellent temperature stability, voltage will get generated across that resistance. This voltage is proportional to the value of the resistance and magnitude of the current flowing through it. So simply what we are doing, so we are passing the DC current through the known resistor, which is temperature stabilized, and measuring the voltage and calculating the current back. So DC current is equal to whatever the reading we are getting in the DMU, that divided by the resistance value. So by using this relationship between the three quantities, voltage, current, and resistance, we are calculating the current. So with this, the uncertainties are, we have taken one example for the 100 milliampere DC. So uncertainty is due to the reference multimeter because always we are using one reference multimeter for the measurement at the output of the resistance, that is a 5.5 microns. Then uncertainty due to the temperature coefficient, uncertainty due to the reference multimeter, uncertainty due to the standard register here, it is which we are using hardly sometime 1 ohm depending on the current to be measured, that is 1.5 microns. Uncertainty due to the drift in the register and uncertainty due to the resolution. So total comes to 8 micron, 8 ppm. So very low because the here my main theme which I am emphasizing over here to minimize the uncertainty because the people are coming with the highly accurate equipment, but there is no system to compare to calibrate them, and that's why we are trying to reduce the uncertainty by effectively using the various systems and the formulas given by the electrical technology. So now coming to the last button, the parameter, that is AC current calibration. So here, comparatively, DC current calibration is very easy as compared to the AC. Here in the AC, the same principle we are used, but the standard registers are not only DC registers, they are the AC-DC registers, where the AC effect and DC effect both are measured, and that difference of AC-DC difference of the register is used here for measurement of AC current. If you see here the formula, see these are the AC-DC registers, and these AC-DC registers are a radial design. Here you see the design, it's a radial design of the high performance with minimum interference from the external magnetic fields. The open design maximize airflow, so the shunts have the minimal power coefficient effects, enabling them to be used over a wide range of currents with a stable resistance. Here, the phase displacement at 100 kilohertz is small enough to be neglected. So with this, we can measure the AC current, and by knowing the AC-DC difference of that particular shunt. See the uncertainties again. There are 3 parts in the uncertainty. Uncertainty due to the AC measurement standard, which we are using at the output of the standard AC-DC shunt. Then uncertainty to the AC-DC shunt, and again the last and dominant factor, that is the resolution of NFC. So maximum for AC current measurement, it goes up to 60 ppm for the AC current measurement. One can get better than this also by using the different equipments. But with this, we have achieved up to the 60 ppm uncertainty in the AC current calibration. Now DC resistance calibration. Again, in the multifunction calibrator, nowadays earlier they were using the different type of active resistors. Nowadays, these multifunction calibrators are coming with the passive resistors. These are again new things they have started. So these passive resistors we can directly calibrate through the bridges also, but we have used a different method. What we are doing? We are using the reference multimeter in a ratio method, in a ratiometric method. So what we do? We are using the true ohm scan mode operation of the reference multimeter, and which stimulates current of alternating polarities applied through both the resistors. I mean, what we are doing in the reference multimeter, we are connecting at the front, and another we are connecting at the rear panel, and that we are measuring the ratio. We are measuring that in the front we are using the standard resistor, which is the known value, and at the rear we are using the device under calibration, that resistor, and we are measuring that this reference multimeter is measuring the ratio. So that ratio we are applying, that ratio we are using to allocate the value or to give the value to the device under calibration. So that method we are using for the measurement of resistance here. With this, what happens, the lot of uncertainties have come because directly we are not measuring the resistance. Yeah, so we are using the transfer, the ratiometric measurement here. So transfer uncertainty of the reference multimeter is 0.71 ppm. If we use direct measurement, direct resistance measurement, uncertainties are very higher. So transfer uncertainty we are using, that is 0.71 ppm. Uncertainty to the temperature coefficient, uncertainty to the standard register, because that we are using at the front side of the front terminal of the multimeter. And of course we are using the drift because standard registers are continuously drifting over the period of long time, and the uncertainty to the temperature coefficient. So maximum uncertainty in the DC resistance goes to the 5 ppm. Now last parameter of the multifunction calibrator is the frequency. No, it's very easy that people are directly connecting the counter, the frequency counter and directly measuring it. But what we are doing, we are not directly we are measuring, but first we are characterizing this counter with the rubidium clock, which is directly connected with through the antenna with the satellite. So first we are characterizing this the counter CNT91. We are having it's a OCX actually, oven based control oscillator. So that we are using first we are characterizing with the rubidium clock, and then we are using to measure the frequency of the multifunction standard. Of course, it is not that highly accurate, that particular system, but the here our uncertainty is the 58 ppm or approximately 60 ppm in the frequency measurement. So these are the this is the way we are calibrating the multifunction calibrator at IDMI. Apart from that, it's not only the multifunction calibrator, several other equipments we are calibrating, because by the name, you know, the full form of the IDMI is Institute for Design of Electrical Measuring Instrument. So our core field is electrical calibration. Apart from that, several other work we are doing: calibration, testing, tool room, design and development, skill development training. So these are the various activities we are doing. So it was my when Dr. Jaiswal has called us that come and make some presentation. So I thought that what we have developed, not developed, what we have compiled, I will not say developed. It's the job of the MPL, not the ITMI. So we have compiled all these equipments and started this facility for calibrating the multifunction calibrator. Thank you very much. Any questions?
Thank you, Mr. Gujrati. Any questions from the audience? There are no questions. I have one.
Yes.
You said you are taking flexibility.
Yes.
So, how much uncertainty are you getting from NPL?
Well,
And
yeah. Please.
and when you claim that you have reached such low uncertainties, how do you maintain the traceability of these calibration setups?
As I told you that this particular here we are using this particular the Josephson this
Yes, yeah.
Jenner. So this Jenner we are directly calibrating from the NPL.
What is the uncertainty that you do?
90 nanovolt.
How much is that in ppm?
0.1 ppm.
0.1 ppm.
Yeah.
And when you
Approximately 0.1 ppm.
from NPL.
Yeah.
0.01.
Oh, sorry, 0.01 ppm. Approximately.
Okay.
Yeah.
Okay.
0.01 ppm.
So for these in-house calibration setups, how do you go about validating these measurements and maintaining their traceability?
No, validation in terms of what you want. Actually, see.
I mean, you were saying that you are trying to minimize the uncertainty.
Yeah.
So how do you maintain the traceability from the calibration that you're getting from NPL?
See, first of all, we are not having only one Josephson junction. Sorry, G Jenner. We are having the 4 in series. So as soon as we get this, right now, so we are collecting it today. So as soon as we will take it, we will create one base value at our end. That value will, and every day or every week, we are noting it that values. And we are trying to find out our own equipment, how much it is floating. And through that, we are maintaining the validity of our standards actually.
And how often do you do the calibration of your
Earlier, we were doing calibration from NPL every 6 months, now every 1 year. Since Dr. Oza was the head, since that I am calibrating this Jenner from not by the comparison method, directly by Josephson.
In 1 year, you don't get any drifts?
We are getting drips. We are getting drips. And that we are continuously monitoring with the reference multimeter. We are getting drip. And that drip, we are even informing to Dr. Sandhya madam also, sometime whenever she is asking, I don't know whether she is here or not, but they are considering that into uncertainty calculation of that. Okay. Because they have the continuous, all the certificates with them. 4 years before, 3 years before, 2 years before. So they are finding out the drip, and that they are directly putting into the uncertainty calculation when they are assigning the value to us. So drip they are considering there itself. This I discussed with them and I understood.
Any other questions? So thank you, Mr. Pujari.
Thank you very much for giving us an opportunity for this making the presentation. Thank you.
Our next presentation is by Mr. Abhishek Chaudhary. And a couple of minutes and introducing himself. Was the last minute change, so I apologize for not having the details. Mr. Abhishek, I would ask you to spend a couple of minutes introducing yourself and then
Yes, sir.
please go on.
Yeah, hello, good afternoon, everyone. My name is Abhishek Chaudhary and I'm working as a calibration engineer at Metrology South Asia Private Limited from last 4 years. And today I'm going to present my presentation on issues and challenges to the 3D coordinate measuring machine for its calibration, verification, and validation. So, coordinate measuring machines are the most advanced dimension measuring instruments available in the market today. The unlimited versatility allows them to be used for an infinite number of measurements. The international standard ISO 10360-1 defines CMM as a measuring system with the means to move a probing system and capability to determine spatial coordinates of the workpiece surface. There are various types of probes that are used for CMM that includes mechanical probes, optical probes, laser, and white light. Demonstrating traceability to a national standard and estimating the accuracy of measurements made with the 3D CMM is an extreme importance for maintaining confidence and reliability in the measurements. So the ISO 10360 series of standard explains the acceptance, verification tests, and interim checks required to determine whether the CMM performs to the manufacturer's stated error of verification. However, even with these tests, it is not possible to make a statement about the length measurement capability of the machine. This is due to the complicated way in which uncertainty are associated with the CMM. So therefore, the length measurement uncertainty derived from the limited sample of measurement cannot be considered to be representative of all the possible length measurement tasks, and certainly not of the measurement task that CMM is capable of performing. So coming to the potential sources of error in CMM, there are different errors in CMM. So it may be due to the accuracy of the components of the CMM, maybe due to the guideways, the scales, the probe system, and the qualification sphere, or it may be due to the environmental conditions, like the ambient temperature, temperature gradient, humidity, or the vibrations. Other than that, the probing strategy used, it may be due to the probing strategy used, the magnitude and the direction of the probe force, the type of probe styles used, and the measuring speed of the probe. Also, it may be due to the characteristic of the workpiece, elasticity, surface roughness, hardness, or mass of the components. CMM basically involves two types of instrument errors or measurement errors. First one is the volumetric length measuring error E. It applies to all measurement of distance, diameters, and positional tolerances. And the second one is volumetric probing error P. It applies to all form measurement of straightness, flatness, cylindricity, roundness, and freeform tolerances. There are different architectures used for the calibration and verification of CMM machines, like step gauge, length bar, wall plate, hole plate, or purpose-made test piece. But it depends on the size of the CMM, so the best way for the calibration and verification, as per ISO 10360, is the step gauge. So this is the spatial position in CMM for the calibration. There are basically 7 spatial positions that are measured. It is along the x-axis, along y-axis, z-axis, in the diagonal xy direction, diagonal yz, diagonal xz, and in the diagonal xyz direction. To verify CMM, basically, to verify CMM meets its specification, a minimum 5 lengths are measured. 5 length measurements are made 3 times each at 7 different positions. So that's a total of 105 total measurements are done in accordance with the 10360 standard. The measured lengths are then compared to the calibrated values of all the step gauge, and deviation must be less than the machine specification for all 105 measurements. So as here you can see, here we are checking with the step gauge, the y-axis. In the second image, you can see the body diagonal measurement. And third image here, you can see the E result of one of the 7 positions. The upper and lower lines specify the NTU maximum permissible error, and here you can see the major deviations, which are lying between the tolerance limit. And fourth one is the probe calibration. The E-test is thorough system test of CMM and is sensitive to machine geometry and scale errors, repeatability, and some probing errors. E is a key test to establishing traceability for the CMM. Since E is also sensitive to thermal variation, it is always specified for a particular temperature range. Machines equipped with automatic temperature compensation usually allow that range to be extended. Now coming to the error mapping is done to calculate 21 geometric deviations that occur in CMM. These deviations are usually of these types. As you can see, for linearity, 3 types are there, straightness 6 type, rotational 9 type, and squareness 3 types. Coming to the standard ISO 10360 series, it is basically a series of standards which were first published in 1994. The ISO 10360-2 has 2 separate tests. The first is the length measuring performance designated as E, and the second is the probing performance designated as R. The E test is complete test of CMM to measure length and important fundamental characteristic of the machine. Coming to the calibration point, calibration refers to a process of comparing the accuracy of the instrument measurements to a known standard. These known measurements are called calibration standards. Any calibration standard used should be traceable, meaning the standard value can be tracked back to the national standard like NPL India. Labs that offer calibration services must be ISO IEC 17025 2007 accredited and use NPL traceable calibration standards. These traceable standards help technicians know that they have adjusted equipment appropriately so it will deliver accurate results. The ISO IEC 17025-2017 provides static standards for labs to follow to show they're competent at performing various laboratory activities. With this accreditation, lab has proven they can properly calibrate specific type of devices. For the verification is a procedure made to help labs to ensure their process or equipment are working in the way they are originally intended to be. The verification process doesn't involve any corrective actions. In this procedure, a lab will use some sort of measuring device to see if a piece of equipment is operating correctly. It can also refer to a procedure designed to check entire process to ensure the process meets its stated operating specifications. The main difference between the calibration and verification is that verification doesn't have any technician making any adjustments. So we don't make any adjustments in the verification process. This procedure also doesn't usually have any technicians checking its result versus any NPL standards. The verification simply helps lab to confirm their instruments and systems are performing correctly. For the validation part, validation is a process designed to ensure different parts of the system function well together to help generate the needed outcomes. After a system's components go through calibration and verification, validation is required to ensure that all components work together in the system to produce the right outcome. The difference between calibration and validation comes down to calibration focusing on an instrument accuracy back to a known standard, while validation is only geared toward making sure that the system meets its stated functional intent. Since validation and verification are often confused, it's important to know that verification checks the process that has right operations. So here are some of the CMMs that are available in the market, which has an accuracy like Vijix from Metrology, which has an accuracy of 0.28 microns. Thank you very much. Any questions you can ask.
Any question? You have given a very nice talk.
Thank you.
think there is no expert in the audience. I'm the person by chance. Otherwise, I have so many questions. I would like to make one comment. With my long experience with the CNN and the calibration, it is so complex machine that even the many assessors, when they go for the assessment, they make mistake. During the assessor conclave, I made this point to the NABL that either the assessor should be trained to use this CNN or there should be some training from the NABL side. This is a really very complex subject. What they are doing, and first time when I went to the CMK, I tell you what I did. Along with the Dr. Tanu was there, along with me. When they have demonstrated the type A uncertainty, so they were taking only one axis, like the x-axis or the y-axis, and they were taking the 10 readings for the repeatability measurements. When we have calculated the uncertainty measurements, I find that their machine better than the NPL machine, and we could not find any defect. By chance, when I went to the PT Germany, I discussed this issue with the speaker, Dr. Turkett. He was supposed to be the father of CNN. And when I said about all these things, then he said to me that you did all the complete wrong thing. आपने calibration गलत किया है. ऐसा होता ही नहीं है. Then I took the training and I discussed many issues with the CNN, complex geometry. Then I came to know that these are the things that we should do it. And later I wrote a letter to the NABL that we made some assessment at CMK Bangalore and we make such mistakes. But still, I did not find any assessor who is competent to make the correct calibration, because if you see the standard of this CMM, it is 10360-2. And it does not say anything about the calibration. It only says that this is a verification or the validation. And I raised this point when I was a committee member of the CMM, then this standard was written in UK. It was the committee. And they also agree that there should be some calibration. Because at that point, in the UQC, give me only 2 minutes. There was some issues because in Europe or America, CNN basically used for the verification, not for the calibration. But nowadays the system is totally changed. Now we find the CNN has the accuracy of better than 0.5 micron, and it is sufficient for the industries. So there is some changes has been there in the latest standard if you see. So this is a change. Technology change, technology development change. So because this lecture is very precise, because in 10 minutes or 5 minutes, it cannot be explained all the parameters. But if you see in details, it will take 2 hours or 3 hours. It is such a complex geometry that for one calculation, we need minimum 105 measurements, which is not possible. And I challenge in India, nobody is taking it. I don't know how they certify the senior. So senior means that this is a volume, it is not the axis. You may write here, you may not be right here. There are different things. So there is a roll error, pitch, straightness, roundness. There are so many errors. There are 21 errors. And nobody is minimizing these errors. Neither they are measuring it. So this is a very hot topic. So thank you.
Thank you, sir. You have given a very clear details that about the CM and then the calculation part. And probably the next generation will follow the but we say that that's very limited. We should have knowing about this. Your
Initially, he was fearing to present this paper, but I said, don't worry, I will take care.
But I have a one query. You said that the diagonal X, Y, Z.
Yeah.
I do not follow what is the diagonal X, Y, Z. You said that diagonal X, Y, and then other thing.
Yes.
But in this case, it's a diagonal in X, Y, Z. What does it mean? See, it's very interesting.
Basically, a particular angle they are keeping so that all three diagonals are covered between them.
This is Z, this is Y, this is X, and this is X, Y, Z. All the angles. X, Y, and Z.
Yes, if somebody doesn't know, then basically X, Y, Z is basically really tricky word if you don't know that what the diagonal is. Anyway, nice talk.
Thank you.
There is one question from online audience. Divya. She has raised her hand, but
Hi forum, I am Dr. Divya Ladwa, far away, joining this forum and enjoying the technical deliverables which all delegates and expertise people are working on that. I have a very specific question, and before I ask my question, I'm so much happy that Mr. Kapi Chaudhary has raised a very vital and very critical point related to CMM. We have a Metrology CMM with us, and probably I'm 100% agree what Dr. Chaudhary has raised the point about the calibration aspects of the CMM. We have been trying to convince ourselves such a beautiful volumetric equipment, which is being calibrated with the help of gauge blocks and step gauges and all that on individual aspects like x-axis, y-axis, and z-axis, where this beautiful equipment is suitable for measuring the volumetric accuracy of the any component and all that. Now, it is still a dilemma for us that we have a very beautiful laser interferometer, which is to be used to determine the accuracies of volumetric accuracies of the CMM. I don't know whether being a manufacturer side, Mr. Speaker, do you recommend to verify the axis of this Metrology CMM by using laser interferometer? And this question probably I'll be asking to Dr. Chaudhary, what would you recommend for this?
Okay, this is really very good question, and I will answer it from the manufacturer side. Because when this machine is delivered, so the accuracy of this machine is checked by the laser interferometer, there is no doubt. But when the machine is delivered to the users, we cannot use laser interferometer for the calibration. The answer is straight. Because laser interferometer here to the users, they can only measure the axis, deviation in the axis, x-axis, y-axis, and z-axis. So we cannot amend anything in the software. We don't have the key of the software, but the manufacturers has a key of the software. They can handle it. So using laser interferometer, we can only find out the deviation in the x-axis, y-axis, and z-axis. But actual calibration or the volumetric calibration, as you are telling, it is only done using either the step gauge, caliper checker, or the gauge blocks, or the length bar. These are the only methods. But if you see the complete detail of the calibration, you have to use all these three and a special strategy for the measurements. But I tell you here, it is not possible to compensate all the 21 errors using laser interferometer because you don't have the approach to handle the software. This is a state question.
Right, I sincerely appreciate. Yeah, Mr. Chaudhary, you use the same statement what Dr. Hageney from Zeiss, Germany. He is also having the same agreement what you said, but then to determine the accuracy of the CMM, like a starter we have from Metrology, by simply using the step gauge and all that, it is slightly dissatisfied because you are claiming an accuracy which is better than what we have been checking with the equipment. So we are getting always very coarser uncertainties for calibration of CMM than what accuracy they are claiming for. So I appreciate. Thank you very much. Thank you, sir.
Okay, welcome, sir. Thank you.
Thank you.
Thank you. And our next presentation is by Dr. Amarjit S. Sarpal, Institute of National de Metrology of Brazil. Dr. A.S. Sarpal is an expert with 40 years diverse experience in the different discipline of analytical science, the development and characterization of the petroleum and related products, catalysts, polymers, and biodiesel, renewable diesel from the vegetable oil, microalgae, and yeast. He has completed his master degree honors in chemistry in 1974 from Punjab University, Chandigarh, India, and PhD degree in analytical chemistry in 1980 from GNDU, Amritsar, India, and awarded all Kitchener Research Award in Analytical Chemistry for the year 2015. Award of Excellence by the International Agency for Standard and Rating, USA. Dr. Amarjit, now you have your forum is for you. You have this.
नहीं चैट में लिख दे कुछ
शेयर नहीं
Dr. Amarjit, are you online? Please unmute. Dr. Amarjit, please unmute your.
स्लाइड तो बंद कर दो
He's not here, it seems.
Okay, looks like Dr. Amarjit is not online.
उसको स्लाइड
We have time for one sponsor presentation. If any sponsor wants to make a presentation, they can make one now.
स्लाइड
Okay, looks like there are no more presentations for the day. So that winds up this session, and I hand over the that to the organizers now.
स्टॉप शेयरिंग बंद कर दो ठीक सबको
I thank to all the speakers for knowledgeable and informative talks. Now I would request the chairperson of the session, Dr. Nita Dilawar Sharma, for felicitating the respected speakers by presenting conference momentum. I request ma'am to felicitate Dr. Radhe Sham with token of remembrance.
ठीक है
I request ma'am to felicitate Mr. Pradeep Gujarati
वेट फॉर करना
with a memento. Now I request ma'am to please felicitate Mr. Abhishek Chaudhary. I request ma'am to please felicitate Dr. Rajiv Gautam with a token of memento. Now I request. Now I request Jaiswal sir to please felicitate chairperson and co-chair with memento.
जसवाल जी इन एचओडी को आप वो कर रहे हो ये उल्टा काम कर रहे हो आप
तो उसका हाथ ले लो, जैसे आपका हाथ है वैसे उनका हाथ है। याद है ना?
In the end of today's program, I thank all dignitaries, all speakers and participants for being here today. I wish you all a good evening. Tomorrow's program will start from 9:30 a.m. You all are cordially invited for the last day of the conference. Thank you all.
Recording